Greetings, I'm Richard Rutledge, and I'm here to preview a live demonstration of our PG-KLEE toolset. PG-KLEE is an implementation of progressive symbolic execution, a general framework for the exploration of program behavior through dynamic adaptation of unconstrained program state with a selectable balance between coverage and feasibility. In our demonstration, we will apply PG-KLEE to several experiments from our ICSE 19 paper. Suppose we have a dynamic analysis requiring inputs to drive every possible program behavior subject to a coverage criteria. By design, symbolic execution is particularly adept at finding inputs satisfying such criteria due to its systematic exploration of all program paths. But in practice, coverage is often limited due to path explosion or solver limitations. One way to get more coverage is to unconstrain more state. Suppose we have a program P with an interprocedural control flow graph as depicted here. We have three functions, main, foo, and complex. Each box represents a basic block, and each arrow represents branches between blocks. Main calls foo with a set of input parameters. In turn, foo calls complex from a loop header. In our example, the lidded body of complex contains code subject to a classic symbolic execution limitation. To obtain maximum coverage, PG-KLEE will progressively add unconstrained state and execute increasingly smaller pieces of P, while only persisting test cases that improve the coverage metric. It starts with standard dynamic symbolic execution at main with symbolic inputs. Then, from each function of P reaching a program point with missing coverage, PG-KLEE executes the function with unconstrained global state and symbolic function parameters. The third phase substitutes unconstraining stubs at a function's call sites. These stubs return a symbolic value and unconstrained output parameters and global state. Finally, for each function containing missing coverage, PG-KLEE unconstrains local state and begins execution at each reaching basic block. The progressive addition of unconstrained state allows PG-KLEE to generate test cases maximizing coverage. Obviously, there's a trade-off between coverage and feasibility of the generated tests because of the behavior of over-approximation. A test case is infeasible if no program input executed from program main reaches the test case entry point with the test case program state. Depending on the effects of coverage versus feasibility on the targeted dynamic analysis, one can tune this trade-off accordingly. If you want to hear more and ask questions, make sure to attend the demo session or check out our tool, which you can find as a Docker image and a permanent archive at the sites listed here.